Let's talk about subtracting with regrouping. This is a pretty challenging topic for a lot of young students, and they often need a lot of conceptual support as they're working on their procedural fluency. What we've learned from Singapore is that number chips are a good non-proportional representation that can be used to help young students understand subtracting with whole numbers, and then can also be used to support slightly older students as they think about adding and subtracting with decimal quantities. So let's take a look at both. In the first case, we're going to start with a whole number, 305, and we're going to represent it on a place value mat using number chips. So when we see 3 in the hundreds place, we're going to have 3 hundreds chips on the mat. And when we see 0 in the tens place, we're going to have no number chips in the tens column. And then, of course, we've got 5 ones, and that's going to show up as 5 ones chips on the mat. If we want to subtract a quantity, let's say 124, we're going to have to test to see if we have enough chips out so that we can take away 100 chip, 2 tens chips, and 4 hundreds chips. And as you can see, we've got plenty of hundreds chips, and we've got plenty of ones chips, but we're missing tens chips. So the first thing we're going to do is take away 100 chip. And when we do that, we are ready then to regroup, unbundle that into 10 tens, and those go in the tens column. And then we can go ahead and actually take away 100 chip, and we have enough tens now to take away 2 tens chips, and we can now take away 4 ones chips. And so from the place value mat, we can see that our answer is 100, 20, 40, 60, 81, 181. So now let's take a look at how to do this with the actual quantities in written form. What we're going to do is we're going to unbundle one of the hundreds, and that's going to become 2 hundreds, and then that 100 was regrouped into 10 tens. So now we're able to do 200 minus 100, we're left with 100. 10 tens minus 2 tens gives us 8 tens, and 5 ones minus 4 ones gives us 1 one. So in this case, we also get the same answer of 181. Now let's take a look at how to use this exact same strategy with decimal quantities. And here we're going to use a starting number of 3 and 5 hundredths. And when we show that on a place value mat with ones, tenths, and hundredths, we show 3 ones and no tenths, because there are no tenths in our number, and 5 hundredths. And if we go ahead and subtract 1 and 24 hundredths, we can do the exact same procedure. We notice that we don't have any tenths, and we need some in order to take 2 tenths away. So we're going to unbundle our 1, and when we do that, it's going to give us an equivalent quantity of 10 tenths, because 10 tenths is the same thing as 1 whole. So now we're all set, and we can take away 1 and 2 tenths and 4 hundredths. And when we do that, we can see that our answer is 1 and 2, 4, 6, 8 tenths and 1 hundredth. So let's take a look at now how we can do that with our written form. First thing we needed to do was to unbundle one of our ones, left us with 2 ones, and when we did that, we were able to show an equivalent 10 tenths. So now 2 ones minus 1 one is 1 one. And we put the decimal point in to make sure that we know that the place to the left of that is our ones place. And now 10 tenths minus 2 tenths is 8 tenths, and 5 hundredths minus 4 hundredths is 1 hundredth. And we're used to having students say 1 and 81 hundredths when they read this, but we're also learning from research from Australia that it's also helpful for students to say 1 and 8 tenths and 1 hundredth. which is exactly what they see when they look at the number chip model. So this is a strategy for helping students make connections between procedures and concepts with both whole numbers and decimal quantities. Thanks.